Hello, and welcome back to the Land and Climate podcast. My name is Alasdair, and in this episode I spoke to two academic experts about the heated debate on the future of solar geoengineering. Adrian Hindes from the Australia National University and Albert van Wijngaarden from the Scott Polar Institute at Cambridge University. Climate geoengineering is a broad-brush term used to describe technological efforts to change or manipulate the Earth's climate, often through attempts to cool it. It has attracted considerable interest in recent years, even becoming the discussion topic of choice amongst conspiracy theorists. And, with the failure of global climate agreements and seemingly sluggish action on mitigation, geoengineering activity has ramped up, with research receiving increased funding and support, and with new and sometimes controversial projects emerging across the world. Adrian and Albert are authors of a recent article, which we link to in our podcast blurb, asking for a more productive dialogue around how solar geoengineering should be developed and used, and with a warning that as the momentum on projects develop, critical voices risk being excluded and ignored.
Some of the technologies, like stratospheric aerosol injection, what their unintended side effects will be, we'll only find out once it's deployed at scale, or the tests are that big that it's already close to a full deployment.
I began our conversation by asking Adrian to explain the kinds of technologies that are referred to as geoengineering.
The most famous and most well-researched one is stratospheric aerosol injection. And the idea there is that you put some aerosols, small reflective particles, into the stratosphere, which is the layer of the atmosphere about 15, 20 kilometers up. Because they're so high up, they last a bit longer. And it's kind of mimicking volcanoes. So most of the time when a volcano erupts, it'll send out a big plume of ash, which contains certain types of aerosols, including sulfur. The sulfur is usually the specific one that's in mind with stratospheric aerosol injection, or it's abbreviated SAI. Though people are looking at a couple other aerosols, which is interesting, is the kind of design problem around it. Everything from light or calcite to even diamond dust. And so there's engineering aspects to it in terms of like, how would you actually get it up there? Stratospheric planes that have to fly higher up than planes had previously. How do you get the aerosols the right size, that kind of thing? The characteristics between these techniques vary quite a lot. So for SAI, it's going to be global, really, or at least contains to which hemispheres you inject it. You can choose the altitude, you can choose the latitude, and then if you want to have the hemispheric cooling balanced or not. But then to compare with another fairly well-researched one, marine cloud brightening, this one's actually very close to home for me. I'm in Australia, and there's been some experiments for this in the Great Barrier Reef where the ships that go out, they suck up some seawater and they spray it into the clouds, and it makes them a tiny bit brighter, so reflecting more sunlight out, and therefore cooling. That one's more of a regional intervention, but it has global effects if you do it enough, and also to have transboundary effects in that you spraying one region, it might impact what they're called climate teleconnections. And so it could do it off the coast of Australia or off the coast of India or somewhere. It might have impact on the Amazon or the west coast of the US or something like that. And some examples of polar geoengineering, they're all fairly new, or most of the proposed polar geoengineering ideas. And you have one that features, for example, in Kim Stanley Robinson's Ministry for the Future, where you drill through an ice sheet like in Greenland or Antarctica to remove some of the water underneath the glacier, either freeze it or remove it physically, thereby slowing down the glacier and getting it into place. So instead of sea level rise, the goal of this would be to prevent catastrophic sea level rise through marine ice sheet stability. Other ideas are designed around the simple idea to make ice more reflective. Ice is already very reflective, ice and snow, but especially in certain forms, it loses some of that reflectivity. So one of the ideas would be to have sea ice, which as snow melts during spring, you have a lot of sea ponds that are formed on sea ice. Whether it would be possible to spread reflective particles on ice, that project recently ceased its operations, but one form of the project is still on mountain glaciers to see if it's possible to make those brighter. You have a lot of dust and other kind of dark particles blowing in, dirtying the glacier. And then you also have maybe also a very visual idea. Another example would be the idea to artificially thicken sea ice by pumping water on top of it. It's
kind of analogous perhaps to what is already being done ice rates or for ice roads in the Arctic, but then on a large scale to preserve more Arctic sea ice.
So both of you, in a sense, are now working on this. I mean, maybe you could just go into your own specific projects.
Originally, it was sort of cautiously optimistic. It's like, okay, here's something that could actually reduce climate impacts in my lifetime. And maybe you can avoid some of these tipping points. And some people have been looking at specifically that potential in our research, especially with polar geoengineering ideas. But as I began to look into it, the intensity of the research topic as a kind of controversial idea really came to the fore. There's really quite a lot of disagreements around how would governance work. Could it work at all? Because this is for something like stratospheric aerosol injection, to make it really clear, this is a relatively cheap type of thing that potentially a single country could do, like in the order of sort of tens of millions of dollars, maybe a couple of billion once you really ramp up. And so it becomes the opposite of the free rider problem in climate, where it's an expensive potentially thing to do for the world. And so you can kind of just lay back and let the other countries do it. Instead, it's like a single country could go it alone, have their hand on the thermostat. So the governance problem is really quite vexed on that side. But then the ethics is interesting as well. So obviously, we could talk at length about side effects of any of these interventions, but I think what really distinguishes it in people's minds and isn't often brought to the fore is that there's an intentional intervention. Climate change was, or at least the longest time, not consciously done in a way. It wasn't done to warm the earth. It was a side effect of industrialization and modern society. The climate intervention of any form would represent humanity trying to interfere with or participate in the regulative processes of the earth, a self-regulating system. It poses some actually quite profound ethical and philosophical questions on that front, which I'm interested in.
So I came into the study of geoengineering ideas as my historian by training, and I learned about geoengineering from the history books. So many of the ideas that are floating around today already had their precedent in the Cold War era. So, for example, the first calculations on stratospheric aerosol injection were done by Michal Budyakov, a famous Russian climatologist in the 1970s. Many of the concerns that were voiced by him in his original book were quite close to the state of the debate as it was. I've only been working in the field for a couple of years, but kind of what I encountered there as well, with calls for moratorium, worries about environmental side effects, the need to get more knowledge, and maybe the difficulties around that. And I was drawn from the study of past projects into the present, especially seeing also that many of the conversations as they were being had weren't done so in a somewhat dysfunctional way. At least that's how it appeared from the outset. And that's maybe also a way to segue into our article, where one of the motivations to write that together was because we saw the polarized debate around this topic, in which people approached this topic from two different sides, one fundamentally opposed and the other more cautious or even pro, in any case, research, and maybe even some extreme sides deployment. And there was hardly a middle field between those two.
The historical point that like so many of the side effects and concerns around like the ethics or governance of that Boudica and others brought up, this is well before the 2000s, right? And then at some point, I think it's Alan Roebuck published a fairly famous paper, 20 Reasons Why Solar Geoengineering may be a bad idea. And most of the talking points there have stuck in both the public consciousness, but also the critical aspect of academic research. And often there's this phenomenon where it's not a perfect split, but the social science or humanities type of critical crowd will cite older research or kind of repeated talking points, things like for SAIs, that it would disrupt monsoons, which insofar they can be confident in climate models, it's probably not the case that it would have that level of disruption. They would dry the atmosphere, cause less precipitation, depending on how you do it. Yeah, so there's lack of updating. We're kind of spinning the wheels in the mud just as the debate goes, because on one hand, the critical side hasn't really updated the talking points on the physical climate side, but the more cautiously optimistic folks haven't really updated themselves on the governance and ethics side either. And they haven't really listened to those points, as far as I can tell, and then taking it seriously as to what that might mean for how research is done, what scenarios we explore.
But isn't there an issue here that also there are so many different types of geoengineering here, and therefore there are actually quite a few different possibilities about, the outcomes, etc. But actually it's quite difficult to have a generalized debate when you need to probably have a debate about specifics.
Yeah, I think that's a very fair point. The paper we wrote was specifically on solar geoengineering. In a way, I think we were specifically also speaking about stratospheric aerosol injection. So that most controversial idea that Adrian explained of injecting some particles in the stratosphere. And most debates have been around that topic, and it remains also by far, I think, the most controversial. It remains the most controversial of the suggested technologies. Around stratospheric aerosol injection, you get an especially clear polarized field. The term geoengineering in itself is also a very difficult one because it, as you say, it collects so many technologies and techniques into it that it's in some way also not so useful to speak about geoengineering as a whole concept. That being said, it's also a term that is nowadays mainly used by opponents, where people who are supportive or of research, they rather use climate engineering, climate interventions, or even climate repair. Down the road from my institute in Cambridge, you have the Center for Climate Repair. So there are a lot of terms flying around, and geoengineering is mainly used by those skeptical to it, because this is maybe also an issue that makes this topic confusing, is that geoengineering is also used in conspiracy theory. It very frequently comes up as a kind of mind control thing that is already ongoing, secret deep state kind of chemtrails kind of theories. So most of the responses we got to our article, even though we thought it was kind of nerdy and very specifically geared towards academics, were by people who believed in these kind of conspiracy theories. So it will likely also gain more prominence, and you already see real world effects of this. For example, in the state of Tennessee, there is being regulation adopted that bans all kinds of geoengineering and climate modifications with arguments mainly derived from conspiracy theories.
So in a way, in this particular conversation, we should narrow our own discussion perhaps towards solar radiation management.
Yeah, 2 points could be made. One is that there's some general disagreements, debates, ethical concerns that would apply to most of the interventions we're talking about. So one would be mitigation deterrence, for example, or sometimes termed the moral hazard. So the idea is that because there's even the possibility of an option to decouple the effects of carbon dioxide and greenhouse gas in the atmosphere to warming, there may be less motivation, less impetus for countries and corporations to reduce their emissions. Every conversation with geoengineering should seriously highlight, like, the number one priority is going to be and always will be to reduce our emissions as fast as we can. These technologies, it can never be stressed enough, like, they're not a solution. None of them are perfect. They all have side effects and unknown unknowns and risks and all that sort of stuff. And the temptation is that kind of a capitalist or technocratic or techno-feudal society is going to just use this as an excuse to continue the fossil fuel industry structure. I mean, Albert, we started to talk a little bit about the conspiracy theories in the background of the public debate or public discussion on it, which is quite a difficult thing for academics to deal with. Often there'll be solar geoengineering researchers that get letters from people who are thinking we're already doing climate interventions of some kind. And, you know, the language games around how it's described, even how I introduced stratospheric aerosol injection earlier, I could have said, it's spraying sulfuric acid in the stratosphere. That is a different feeling to where lofting reflective aerosols to cool the planet. And so there's those sorts of effects. There's the complexity of the ethics and the governance. What kind of governance infrastructure would actually work at the international level for countries to deliberate and come to a decision here? It's profoundly complex, and we've already seen the abject failure of the UNFCCC process, if we're transparent about that. So there's the general kind of sense of governance and ethics for most. But then when we get to the specifics of whether or not it would be worth doing, whether or not it's risking it, if you like, then the details have to come out of, like, what is actually the purpose here? Is it to save a glacier? Is it to save the barrier reef? Is it to cool the entire planet? What kind of decisions and choices are made of how exactly it's done? Because how much cooling you do, where you place the post-warming cloud brightening, how much you do in sort of polar interventions. These are all important decisions that change what it actually looks like at the end of the day.
Most of the research into geoengineering is in its infancy. Most of these technologies are theoretical, largely existent in climate models. There are some technologies that are now at the start of being tested in outdoor experiments. There is some material development, technologies like marine cloud brightening to make marine clouds brighter. The nozzles are being developed. There's testing with spraying patterns, all very small scale at the moment. But technologies like stratospheric aerosol injection are hugely controversial whether at all outdoor experiments should ever take place. So you have, for example, a call for the non-use agreement. That's a call for a moratorium on research on stratospheric, on solar geoengineering, or on research. I should specify that it's not a moratorium call for research on. It's for a specific kind of research. No outdoor experimentation, no patenting. They have a couple of key concerns, but we are in a state in which research is at the point of scaling up, or at least of expanding. And that's one of the other motivations why we wrote our article. There's recently been a relatively large funding spree by foundations, philanthropic organizations, but also governments. Now, in terms of large research projects, the amounts of money being spent on geoengineering is still relatively limited, but it does represent quite a significant increase in the terms of going from hundreds of thousands to a couple of million to tens of millions of dollars per fund. And some of these resources are also earmarked potentially for outdoor experiments. So it is in the foreseeable future quite reasonable to expect that these developments will take place. And that comes on top of a few very controversial private enterprises, the most notable being Make Sunsets, an American startup, and US-Israeli company called Stardust, who are focusing on stratospheric aerosol injection. Make Sunset actually sells cooling credits, so you can pay them money to launch a balloon into space, which almost all scientists deeply disapprove of. And Stardust is a lot more secretive, has quite significant funding also, and is studying the kinds of material that could be used, a monitoring process, the distribution. So they are already quite underway. So it's also one of the other arguments in our paper was also that it's quite reasonable to expect future scale up of resource and maybe also field experiments, and that even though opponents of geoengineering really want to have a hard no on the table as an option, so that no, we shouldn't do this further, given the state of the world with increasingly dire effects of climate change and these private research pushes, but also funding that increasingly becomes available, that no is perhaps a bit difficult to have as hard as some people would like. It's probably a good thing to try and get round the table to, even though that might be very difficult, to come to some kind of constructive way forward, which could be agreeable, or at least to a certain extent agreeable to many parties. That being said, that's a very difficult thing because the opponents, they have already clearly said, no, we don't want this. So to ask them to come back to the table is a bit like, no, of course not. That's a difficulty. And the people who are supportive of research, they get now the funding. They have, to some extent, also tried to engage, but haven't done so successfully. So there's also an incentive for them. Why would we, again, sit down for the table to people who fundamentally object to everything we do? There's a fear of a slippery slope effect in the research. And the researchers on the kind of more system modeling front just trying to see like how would this work technically from an engineering or planning physics point of view. It's difficult to speak for them, but I think that there's less of a felt sense of that kind of concern. There's a more separation between, this is a conceptual idea that we're thinking through researching just in case. If it is going to happen, it would be regrettable regardless. It's not something that we want to have happen in the future of the Earth. It's still like, well, we ought to do the research so that at least it's the least worst kind of deployment possible. But it has that very strange tension where maybe the research itself is driving the conversation forward. And that's a very hard conversation to have between those two sides.
Maybe go into some of the nuances of how, for example, solar radiation management can work on, for example, a smaller scale. Whenever we're talking about this, we're always thinking of it in terms of global impacts, etc.
So one of the things also about stratospheric aerosol injection, it will be global. It's per definition one of the most of the global technologies of the geoengineering ones. You will have effects around the Earth. Maybe they will be distributed, but it's no way, you cannot control stratospheric aerosol injection. Some of the other technologies have that option. They are, so for example, some labeled these polar geoengineering technologies as targeted geoengineering, where you have a relatively limited scale at which you deploy. So you will have unintended side effects. You probably will always have that for each technology you deploy, but they will be fairly limited and localized. So, for example, there are ideas to stabilize ice sheets, for example, by blocking some warm water currents in front of them. Now, the physics of it all is much difficult, but this is one of the ideas in polar geoengineering, which, irrespective of the feasibility of this idea, it would likely only have local side effects if it would be deployed in a hypothetical future. And therefore, it could be seen as less objectionable than the global technologies. Moreover, it could perhaps focus on these these are controversial, but tipping points, depending on your definitions of my partner is a physicist, so I get this a lot, but you have to be exact about what you mean by a tipping point. Is it irreversible? Is it nonlinear? Is it a surprise when it tips? Whatever your definition of a tipping point, there are several around that are at risk. So you have people worrying about AMOC, the Atlantic Meridian Overtrain circulation, that could shut down at some point. You have ice sheets that could collapse. So you have various these tipping points, many of which are in the polar regions, so the cold parts of the world. And some of these targeted or polar geoengineering technologies have been specifically thought up with the idea of countering these kind of tipping points. One of the arguments sometimes made for geoengineering is we're already too late. This is, you had Malm and Karjan in your podcast as well about with the idea of overshoot, in which they also outline a similar kind of trajectory where we set the target of 1.5 and, oh no, we're already at the target. So what should we do now? We have an overshoot. So there's also an overshoot commission who thinks about what to do with this. And even though, of course, 1.5 is just a number, there are some indications around that temperature that some of the critical tipping points will be crossed. So one of the arguments for geoengineering made by some is we're in such a bad state, we need to do something. Then what is that something? Well, some people frame geoengineering as an emergency brake, also a really controversial technology, but some of these targeted interventions have been designed specifically to help with these tipping points. It's not certain that is possible or feasible, but just to show also the diversity of different technologies that we're speaking about under that big umbrella name of geoengineering.
And just quickly, a nice in between example is marine cloud writing, since coral reefs are often included in the list of tipping points. And that's, huge set of ecosystems across the planet and mostly the tropics. It's funny because I've had a look at kind of the split of opinions there, and you'll have the climate physicists and modelers and some of the engineers working on it fairly sanguine about the possibility of having boats out to cover the Great Barrier Reef, an extremely large area. I think the size of, I should probably edit this out if I'm wrong, but it was like Japan or something. But there's a couple of very famous reef scientists in Australia that have briefly looked at this and it's like, this is ridiculous. Like, you're not going to get that many boats out to the size of the reef. And even so, it's not just ocean, like marine heat waves. You also have kind of thorn starfish in Australia, and no doubt a whole bunch of other drivers depending where else in the world you are. It's a regional intervention, but that one has teleconnections. And so it has sort of sub-planetary, sub-global scale effects as well, where, maybe it doesn't affect the whole planet, but it could affect something in the other hemisphere or very far away that you weren't intending at all. And there's some modeling that tries to disentangle that, but that's super uncertain. Like, there's not really any way that we're going to be at all confident of those sorts of effects, in my view.
And maybe to add on to that, what Adrian also said, that some of these technologies, we are perhaps able to find out more about them by doing research on them. But some of the technologies like stratospheric aerosol injection, what their unintended side effects will be, we'll only find out once it's deployed at scale, or the tests are that big that it's already close to a full deployment. So it's also very, very difficult. But what people who are supportive of research would say, yes, it can be very dangerous and there are many risks involved, but we need to do this seriously because we need to think about this seriously, because we can't just pretend like if we don't do anything, we're in the same stage. We have to weigh the potential of researching and maybe even thinking about deploying this against the world we would be in without geoengineering. And we think that in a rapidly warming world, that it will be also many serious negative effects. Again, this framing is also controversial. Some people don't like it.
The unknown unknowns point is a great point to segue to a more general governance issue, which applies to most of this. Just that, so if you have some side effect that maybe you had some foresight on, like a model could show that's a possibility, but you can't be certain that in this particular case, this deployment of stratospheric aerosols or a particular polar deployment that maybe has an unintended effect on an atmosphere-ocean interaction and their circulation pattern. A country possibly isn't even involved in the governance mechanism around it, then sees that as impacts on it that other countries did. So the blame game goes around the planet for modifying the climate. And this is actually similar to issues that were brought up with weather modification, which is a close history with geoengineering that Albert, you definitely know much more about. But it's those sorts of transboundary effects where countries and decision makers are going to disagree over responsibility and whether it's even, was it our fault the signal to noise ratio is too low?
And if you have transboundary effects and this difficult of a governance issue, the question who gets a seat at the table, who gets to decide, or who should even decide, because of course who physically gets a seat at the table depends on all kinds of ways the political system that we live in is structured. But maybe the question who should, in an ideal state, get a seat at the table is also extremely complicated. And how should we weigh these concerns? Both sides of the polarized debate bring up the global south as an argument for their case, where the people are against further research. This is just like Adrian explained earlier. This will lead to mitigation deterrence. This will be a slippery slope. This is just a new colonial enterprise by rich countries that don't want to make fundamental changes, but seek the easy way out. Whereas people who are in favor of geoengineering say, yeah, but this is something the global north can work on. This is something the global north can pay, and it will benefit most the countries around the world who don't have the money for climate adaptation. So both sides of the debate use the global south card for their argument.
It'd be hard to speak to it directly, but some global south researchers themselves will disagree on this as well.
Maybe to clarify that a little bit, most of the research done on solar geoengineering is done in the global north by people at elite universities. So even though there are now attempts to diversify the people who are engaged in research on solar geoengineering, at least until the present, it's mostly been the global north kind of thing. So hence the argument against the global south comes from that kind of perspective.
You've been very good at setting out the different arguments and the different angles. I'm still interested in what actually, given that we're talking to you, what you think. Are you able to take a position?
From my perspective, I feel there is already so much of position taking. And maybe also to clarify that, I think polarization has a function. Like in politics, polarization has a function, activism has a function. So it's not to say that all the conversations should be full of compromise. Everybody should sit down at the table and be quiet and polite and let the others speak. I don't think that's the case. That being said, I do think that there are already so many strong opinions floating around. And I do not think they need more people just shout their opinion. I don't think that's a good way forward. I think there should be more attempts at reaching some kind of middle ground or translating or negotiating, mediating different stances.
There is also the lasting problem of we can't sit on the fence. And in including the decision not to deploy, that is also a decision. My view is that it's potentially one of these things is almost inevitable in terms of purely physical climate sense and what it is that we care about as far as human health and harms and even the biosphere as a whole. And yet I think simultaneously we're not ready as a civilization to do that. We haven't really taken responsibility for so much of the environmental harms beyond just climate change. It almost feels like we're not mature enough as a planetary civilization insofar as we can be called the entire thing. It's hard to think of it as a whole now with the way geopolitics has gone. The lack of sincere and serious conversation around just climate change doesn't bode well for this type of thing.
I would add that it's morally also such a difficult stance that really, at least from my perspective, also I switch my opinion, or I don't switch it fully, but there's a lot of going back and forth with regard to some of the arguments that are made. And especially in today's global political situation, it is very difficult to see what the right stance will be. And history will judge us, of course. As a historian, it's maybe a cheap thing to say, but it's very difficult from the present to see what the right ethical approach to this would be. For example, with the new US administration, it's very unclear what that will mean. They've already retreated from some of the international climate negotiations. In some ways, geoengineering would fit perfectly in this kind of Silicon Valley techno-optimist vision of the future. But on the other side, from the MAGA perspective, this is all a hoax. So it's very uncertain what this will mean for geoengineering research, what kind of extreme events will happen in the world, how climate change will develop. You have now talk of an accelerating warming trend. It's very uncertain which position to take. And of course, that doesn't mean you shouldn't take a position, but at least it calls for a certain kind of nuancing of your own understanding and an honesty towards all the other arguments that are floating around.
Thanks very much to Adrian Hindes and Albert van Wijngaarden for their time. We've put in a list of their suggested further reading in our podcast blurb, which references some of the issues and articles they bring up, as well as their own most recent article. Thanks also to Vasco Kostovsky for audio engineering the show. As ever, do check out the Land and Climate Review website for new articles and features, and also do like us or give us a review as it helps others find us. Thanks again for listening, and until soon.